Hello students, this is Mr. Boggs, and I've created a series of videos on the best way to learn mathematics, and for that matter, most of your other subjects as well. And then once you've learned it, how to then best remember it. And this, of course, is important now that we have an external exam at the end of year 12. So we're going to start by having a quick look at how our brains work, what's called neuroplasticity. So there's basically three parts of the brain we want to look at. Excuse me, what's called sensory memory, where all the information at the moment that you're seeing, listening to, feeling, etc., all of that's coming into your sensory memory. Some of that goes into your short-term memory, and then some of the information in your short-term memory then goes into your long-term memory. And of course, you then can retrieve that information from your long-term memory. So let's just see how this actually works. So in your sensory memory, what you're sitting right now, you're hearing me speak, you're looking at the screen, you might feel the wind touching your skin, etc. So information is coming into your brain from all of your senses. Now there's too much information for the brain. So what it does is it has to decide what to keep and what to discard. And the vast majority of what you're sensing right now gets discarded. So in just even a few minutes' time, you won't remember what you're feeling exactly right now. But some of the information that's come in, it might be what I'm speaking about right now, you think about that, and that ends up going from your sensory memory into your short-term memory. So your short-term memory, also called your working memory or your conscious memory, this is basically what you're thinking with right now. So when you're actually using your brain, you're actually using whatever information is in your short-term memory. And brain scientists have said that the short-term memory can't hold much information. In fact, it can only hold 4 to 9 chunks of information at a time, where a chunk could be something simple, like it could be, for example, just 1 plus 1 equals 2, but it can also be something more complex. So for example, an expert student in, say, year 11 or year 12 might be able to have a chunk that is solving simultaneous equations. So instead of having to think about each one of those steps individually, which is what they have to do when they first learn it, they've put all of that information together and they've made chunks, a chunk out of all of that information. And that just becomes one piece of information rather than many pieces of information. By the way, moving information from your short-term memory into your long-term memory is called encoding, and then retrieving that information is called retrieval. So here's what chunking looks like. Information that's going into your long-term memory is like separate small pieces of information. But when you start to reflect and elaborate on that information, in other words, you think about it for a while, what can happen is all of those small chunks of information grow together or bonded together to make a larger chunk, a much more complex chunk. And this now becomes a single piece of information as opposed to each of these being a single piece of information. So it's really important that you can actually learn to chunk your information into more complex chunks. So here's your long-term memory. These blue dots, dark blue dots, represent information that you can remember at the moment. So if you need to recall, for example, the capital of Australia, that could be that one right there. The capital of Australia is Canberra. That could be that piece of information right there. And the lighter dots are the ones that you're starting to forget. And you're also starting to chunk some of your information. So all of this information in here has become a single chunk because you've thought about it and reflected about it. So how many chunks of information can your long-term memory hold? And the answer is, according to brain scientists, an almost infinite number of chunks of information are in your brain right now, and they haven't discovered any limit to that. So there's no limit, as far as we know, to how much information you can hold in your brain at any one time. The trouble is, some of that information is easy to retrieve, and some of that information is difficult to retrieve. So once again, the light blue circles represent information that you're forgetting. Even this chunk right here is a lighter color than that. And that represents that chunk, you haven't used that for a while. You haven't remembered it for a while. And the links to that are getting weaker. And it means it's going to be harder to recall that chunk of information in the future. So the light blue circles, think of that as use it or lose it. If you don't keep recalling information from your long-term memory, it's still there, but it gets harder to retrieve it, which means it gets harder to bring it into your working memory. Now, tricky question just here. What is the opposite of remembering? The answer, of course, is forgetting. So the question is, how do we counteract this? What can we do to minimize how much we forget? So back in the 1880s, Herman Ebbinghaus actually did some research and came up with the forgetting curve. So let's say that you're in class and you learn 10 new words and the definitions of those 10 words. Well, in just 20 minutes, you've lost 40%. You've forgotten 40% of what you've learned. It's still in your long-term memory, but you don't have the links to it anymore. It gets hard to retrieve. After an hour, you're down to only remembering about 40 or 50%. And after a month, it could be down to as low as 20% or less. So the information is still there. You never forget anything that you've learned. But what can happen is retrieving that information becomes more and more difficult. So how do we fix that problem to make the retrieving easier and easier? So what is the most effective way to counteract forgetting? And the answer is, excuse me, spaced retrieval from long-term memory. So what exactly does that mean? Okay, here's a spaced retrieval diagram. So here's when you first learn something. This is the forgetting curve. It's going down, 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 down. But if you then retrieve that information from your long-term memory by thinking about it, then once again, you now have that information is now more easily accessible. You remembered it all. Then it starts to forget, and then you retrieve it again, starts to forget, you start to forget, you retrieve it again, and so on. Now notice, this time you're learning at the start, you're forgetting very quickly, but the more times you retrieve it, the slower your forgetting takes place. So retrieving basically means that the information's back, has strong connections back to your short-term memory, but it also means that you're forgetting it much, much slower. So in a maths class, you might have learned something in class today, you're starting to forget it, but then when you do the homework that night, then you remember it again. You've retrieved it from your long-term memory. And then you start to forget, but then when you have a question in your warm-up at the start of the next lesson, what I call do nows, you remember it again. And then you start to forget, and oops, and then maybe at the end of the week, you might have a diagnostic test. And then once again, either when you're practicing for the test or after you go through the answers, once again, you remember it. So this is spaced retrieval in your math classroom. And the more you do that sort of thing, where you're retrieving information that you've learned earlier, the less you're going to forget. So key point number 1, spaced retrieval is essential for remembering what you've learned. But not all methods of retrieving information are equally effective. Some basically allow you to remember more, and some of them allow you to basically mean that you remember less. So here's 7 different ways of retrieving information. I want you to stop the video if you wish to, and see if you can arrange those from the most effective to the least effective. And then what I'm going to do now, I'm assuming you've just stopped your video, and I'm going to give you the answers. So the best ways to retrieve information from your long-term memory into your short-term memory. Number 1, this is where you're going to do your spaced retrieval in class, but also do your homework. So do your homework consistently, because every time you do that, then you're retrieving information from your long-term memory into your short-term memory. And ideally, when you're doing your homework, you're not just doing questions on stuff you learned today, but you're also practicing stuff that you learned yesterday, stuff that you learned last week, and even stuff that you learned last year. Because again, the whole point of that is you're retrieving that information from your long-term memory. The second thing that's really important is practice under exam conditions. In other words, you're not looking at your notes, you're not working with a friend, you're basically doing the questions exactly as you would do when you're doing them on an exam. So that means you have to retrieve it from your long-term memory. You can't use other sources to help you out. Now, what do you do if you can't do that? In other words, you're trying a question that you did in class today for homework, and you can't remember how to do it. Well, that's when you can, if it's in class, you could ask the teacher for some help, ask a classmate for some help. If you're at home, you could ask your parents for some help if they happen to know mathematics. You could go back and look at your notes, look at your notes and use that, or you could find a worked example in the textbook. So you try to do this, and if you can't do that yet, then you use these methods to help you remember how to do the question. Once you've done that, then you go back and try the question again, or a similar question under exam conditions, and keep doing that until you can actually do that successfully. Now, what about cramming for an exam? Well, if it's the night before a test, or the night before an exam, cramming actually is quite effective for that one short period of time. So the night before an exam, you spend 3 or 4 hours just going through again, practicing, going through and doing questions for the exam, and that will work wonderfully well, but only for that exam. If you then had to do the exam again, say a week later, you're going to forget most of what you learned by cramming. So cramming, putting in 3 or 4 or 5 hours just before the test will work, but only for that test, not for long-term memory. The two worst ways to actually retrieve information from your long-term memory is just rereading your class notes. The problem with that is you're not actually getting it from your long-term memory, you're getting it from the book or the notes that you've written down. And that means you get this feeling that I understand this because you're rereading something you've already done. You think, oh, I understand this, I can do it. But that may not be true. The only way to tell if you can actually do something or not, or if you really understand it, is to practice under exam conditions. And finally, the worst way you can possibly retrieve information is to just go ahead and copy someone's homework because you have to have it done because your teacher's collecting it that day. So yes, it looks like you've done the work. It's in front of you. You've probably learned a little bit by doing that, but not very much. So that's the worst way to retrieve information from your long-term memory. Now have a look at these two arrows here. This is information that's being retrieved from your long-term memory into your short-term memory. Maybe you're doing a question and you need some of that information to solve it. What's the difference between A and B? And pretty obviously, A has greater retrieval strength. So this piece of information, as soon as you think about it, it's straight into your short-term memory. So it's fast, it's strong, it's powerful. And that means it's also going to be much harder to forget in the future. It's still going to be there in a month's time, as opposed to B. So how do we build up this really, really strong connection between the long-term memory and the short-term memory? And the answer is, in just a few words, A has greater retrieval strength. I think that might have been there before. Sorry about that. So A has the greater retrieval strength. And how do you build up that retrieval strength? How do you increase your retrieval strength? The answer is repeated, effortful learning. So the repeated just means your spaced practice, but how you practice makes a real difference. Effortful learning is the key. And the second key is once you've solved a problem, you spend a little bit of time reflecting and elaborating on the answer that you just wrote down. So let's talk about effortful learning, because this is the key to remembering. First, do all homework, classwork, and quizzes under exam conditions if you can. So once again, when you're first learning, you probably can't do that. That's because that information isn't yet in your long-term memory, and that connection between the long-term memory and the short-term memory is not very strong. But that's your goal, is to basically do all that work under exam conditions. It's also very important that you check all the answers, and do that as soon as you answer a question. Check it straight away. The reason for that is if you did it incorrectly and you don't check it, that's going to be in your long-term memory. You're going to start to build up the strength of that memory, even though it's incorrect, because you haven't done anything to change it. So check your answers as soon as you finish a question. Okay, spacing. Revise a topic just as you are starting to forget it. So you're better off doing a question, getting it correct in class, and then not doing a similar one to that, unless you're still a little bit not sure. But the best thing to do is once you can do a question, leave it, go on to another question. Maybe that's a little bit more difficult, or it's the next stage of your learning. Once you get that one correct, go on to something else, but then come back to those questions that you did, maybe the next day, maybe a week later, and try them again. The best way to revise a topic is to basically do it just as you're starting to forget. That's when you're going to basically build up that connection between your long-term memory and short-term memory and make it as strong and as fast as possible. Now, some students like to do the easy questions in a textbook or in class, and that's because they get them correct, it makes them feel good, etc. But the problem with that, number one, you're not learning how to do the hard questions. And number two, you're not really building up the connections between your long-term memory and your short-term memory. It's the effortful learning that makes those connections stronger and faster, not just remembering, but it has to be difficult questions that you're remembering. So your job is to practice doing questions that you find challenging. So if you get a bit of flexibility in your homework, say you're doing a particular exercise, do a question. If you get it right, go and say, okay, what's the next one I'm going to try? Well, question 4. We did that in class today, but I found that a little bit difficult. I'm going to try that one next. But maybe don't go and do the last question in the exercise, the one that you're not quite ready for yet. So practice doing questions that you find challenging, but for the most part, don't do the questions that are so hard at this stage that you pretty much find them impossible. It doesn't hurt to do those. In fact, it can be very beneficial, but it's probably not a good idea to try that over and over because it gets discouraging. If you're trying questions, you're not able to do them. You'll be starting to think, oh, I really can't learn this. And all that really means is you're trying questions that you're not quite ready for yet. So you're doing the questions that are challenging but not impossible, what I call Goldilocks questions. Not too easy, not too hard. And really, really, really important, after solving each problem, rather than just moving on to the next one, once you've done it correctly, that is stop and reflect and elaborate on your answer. So let's say you did a question that you found a little bit challenging, but you got through it. So number one, give yourself a thumbs up. High five, you did it correctly, well done. And then stop and think, okay, what did I have to do to get that answer? What was the first step that I had to decide to do? What were the other steps, the order of the steps that it took me to answer the question? How does this connect to other things that I've done in the past, etc.? Is there another way to do it? That's another thing you could ask yourself. So don't spend a lot of time elaborating and reflecting. On average, 20 or 30 seconds. So for the really easy questions that you did without having to think very hard, just elaborate and reflect for just a few seconds. And the ones that you found really challenging, once you finally solved them, those are the ones you want to spend more time thinking about the solution, maybe just trying to remember in your head what the steps were to get to the answer, etc. So, key point number 2, to maximize how much you learn and remember, your learning must be effortful. There's a brain scientist called Robert Bajork, I don't know how to pronounce his last name. He calls these desirable difficulties. In other words, if you're finding it difficult, that means you're doing the right thing. You're learning more by doing questions that you find difficult as opposed to ones that you find easy. So, key point number 3. If you're choosing to do effortful learning, where you're challenging yourself as you're doing questions, you are going to make mistakes. You are going to make lots of mistakes. You're also going to find that you're trying to do a question and you're getting stuck. You don't know what to do next. And all of that is good. That's basically good mistakes. It means that you're trying the challenging questions and not the easy ones. So good mistakes are a positive. What you do want to avoid are bad mistakes. Oops, here's one right here. So these are the mistakes that you don't want to repeat. So if you're basically making mistakes, like you're copying down one line of working in a question to the next line and you accidentally change a plus sign to a minus sign, that's a bad mistake. If you're making silly mistakes like that, those are the ones you want to avoid. But effortful mistakes, because you're trying really hard, are good mistakes. Now, you've probably heard about growth mindsets, so let's just have a quick chat about growth mindsets. So, the most important thing to realize about our brains is they are not fixed. 10 or 15 years ago, pretty much even brain scientists said the brain you were born with is the brain you have. And neuroplasticity, which is the study of how our brains change, has shown that that's not the case. Our brains are not fixed from birth. So, first off, you can't actually grow the actual size of the brain. Basically, your brain's inside your skull. You can't make it any bigger than the size of your skull, so that's not what's growing. But what you are growing is basically the strength and speed of the retrieval pathways. So something that you would have had a hard time remembering a couple of days ago is now easy because of your effortful learning. And by doing the reflecting and elaborating, you're also building up the complexity of the chunks of knowledge in the brain. So what would have been 10 or 11 things you had to remember now just becomes one thing you have to remember: simultaneous equations. As soon as you see a simultaneous equation, all that information to solve it pops into your short-term memory as a single chunk. Now, the secret to basically building your brain, making it grow, is persistence. In other words, you try. If you fail, you try again. Your thinking has to be, I can't do this yet, but I will be able to do it. So the amount and level of effortful learning, your persistence, is going to be the key to growing your brain. And once I started to read about growth mindsets a few years ago, every time I read about somebody that was doing something exceptional, highly successful in their chosen field, I said, okay, how did they get to that point? Were they born that way? And the answer is 100% of the time, it was effortful work and persistence. So some people are born, for example, more flexible. They're going to find it a little bit easier than the rest of us, for example, to do ballet if they want to do that. Some people are born taller. They're going to find it easier to be successful in basketball. So what you're born with is important, but that's like 5 or 10% of your success. The other 90% is your effort and your persistence, not giving up. Saying, I can do this, I can't do it yet, but I can learn to do this. So recapping what you've hopefully learned in the last 20 minutes or so. Number one, if you want to remember stuff and not forget it, you have to use spaced retrieval. You have to go back and recall something, not straight away necessarily, but over time. So maybe a day later, and then the next time a week later, and then a month later. The second important thing is learning should be effortful. If all you're doing is choosing the easy questions to solve, then you're not going to be learning as much as if you choose the challenging questions to solve, the Goldilocks questions, ones that challenge you but aren't impossible. Good mistakes are essential. If you're not making mistakes, you're not challenging yourself enough. Mistakes help you think. And the last thing is your brain grows. So how it grows is not, again, physically, but it's in building up the complexity, first the amount of knowledge in your brain. So here we don't have too much knowledge in the brain. Here we've got a lot more knowledge, and also building up the chunks. By elaborating and reflecting, you're connecting the information in your brain into larger chunks. Instead of having to just recall a single piece of information, you can recall a whole chunk of information. So that's the end of part one, the first video. So here's information still to come in subsequent videos. So we've taught you now how once you've learned something, how to best remember it. So in part 2, we're going to show you the best way to learn it in the first place. We're going to talk more about elaboration and reflection because they're so important for remembering and building up the complexity in your brain. We're going to talk in particular the best way to spend your time doing your homework. So 2 students can be sitting doing their homework for half an hour, and 1 student has learned heaps, and 1 student has learned a lot less. So if you're going to spend a half an hour doing your homework tonight, there's ways to do it better than other ways. Also, we're going to talk about the importance of diagnostic testing, what I like to call assessment for understanding or assessment for learning. That's what the teacher gives you sometimes, so the teacher can find out what you still don't know, what you do know and what you don't know, but you can use that as well to find out what you still have to practice because you, for example, were given a question on a quiz and you couldn't do it. So assessment for learning, diagnostic testing is critical for your learning. And finally, a really interesting topic is called focused and diffused thinking. So if you get stuck on a question, believe it or not, the best thing to do is stop doing it for a while. Your brain will actually continue to work on the question while you're doing other things. And that's called focused thinking and diffused thinking. We're going to talk to you about that as well. So, thank you very much for listening, and hopefully you'll watch the second video and learn about those things. Thank you very much.